This is a recording to show you how to solve an inequality involving absolute value on both sides. Our problem is absolute value of x minus 1 less than or equal to 2 times absolute value of x plus 2. Recall that if a and b are positive number and a is less than b, then we know a squared will be less than or equal to b squared. This will help us resolve the inequality. Recall that absolute value of x squared is also equal to x squared. This will help us to remove the absolute value. Now apply this to this inequality. X minus 1 absolute value will be less than or equal to 2 times absolute value of x plus 2. When you square both sides, inequality will still remain. However, when you square them, you remove the absolute value. So it just become x minus 1 squared less than or equal to 4 times x plus 2 squared. Now x minus 1 squared is x squared minus 2x plus 1. X plus 2 squared is x squared plus 4x plus 4. And you multiply the 4 on the right hand side, you get 4x squared plus 16x plus 16. Now subtract x squared minus 2x plus 1 both sides. Then you get 0 less than or equal to 4x squared plus 16x plus 16 minus x squared minus 2x plus 1. And the right hand side combine to 3x squared plus 18x plus 15. If you divide both sides by 3, then you will have 0 less than or equal to x squared plus 6x plus 5. Now x squared plus 6x plus 5 can be factorized as x plus 5 and x plus 1 multiplied. So how do we solve the inequality? Setting x plus 5 equals 0 and x plus 1 equals 0, we get x equal to minus 5 and x equal to minus 1. So the whole real number line is partitioned into 3 parts. X less than minus 5, x between minus 5 and minus 1, x greater than minus 1. So now we will set up the sign diagram to find out the solution. So if x is less than minus 5, take for example, suppose x is minus 6, then x plus 5 will be negative, x plus 1 also negative. So the product x plus 5, x plus 1 will be negative times negative become positive. If x between minus 5 and minus 1, for example x equal to minus 3, then x plus 5 will be positive, x plus 1 will be negative, and the product x plus 5 times x plus 1 is positive times negative, you get negative. If x greater than minus 1, say x equals 0, then x plus 5 will be positive, x plus 1 also positive. So the product x plus 5, x plus 1 will be positive times positive, you get positive. Now we are solving this inequality x plus 5, x plus 1 greater than equals 0. So the solution must be here, x less than minus 5, x greater than minus 1. So the solution set includes x less than minus 5, x greater than minus 1, and also include the endpoint x equal to minus 5, x equal to minus 1 because of equality sign here. So that will become x less than equal to minus 5, x greater than equal to minus 1 after we include the endpoint. So in the interval notation, this can be written as from minus infinity to minus 5 including minus 5, union from minus 1 to infinity including minus 1. That's the end of the recording.